Hi guys, welcome back to my channel, and today I'm going to show you how to do question number 3 exercise 11.2 of chapter level constructions of grade 10 max textbook. The question as it is being shown is to draw a circle of radius 3 centimeter. Take 2 points P and Q on one of its extended diameter, each at a distance of 7 centimeter from its center. Draw the tangent to the circle from these 2 points P and Q. So the question is simple, so we can directly start our construction. So take a compass and take 3 centimeter, and then we have to draw a circle. So here it's 3 centimeter as I preferred in the last videos. I again prefer sharp pencil for more accuracy. So taking 3 centimeter in the scale in the compass, and we are drawing a circle of 3 centimeter. Here we are drawing a circle of 3 centimeters. So we have to catch on one point and then draw a circle of radius 3 centimeter. Like I'm doing here, drawing a circle of radius 3 centimeter. So that's the first part of the question, to draw a circle of radius 3 centimeter. The second part is to take 2 points P and Q on one of its extended diameters such that just at a distance of 7 centimeter from its center. So it means that we have to draw one diameter, like there can be many diameters, right? So here you have to take one diameter. So suppose if I'm taking this diameter, so if I'm taking this diameter passing through the center, this is the diameter I'm taking here. So suppose this is the diameter I'm taking. This is the center and I name it O. So this is the diameter I'm taking, means that they're asking us to take 7 centimeter from the center. So from O, I have to take 7 centimeter on this side and this side, such that they both are on the same extended diameter. I repeat again, we should take 2 points P and Q, both on the same extended diameter, this diameter, both on the same diameter, but on different sides, like here and here. So here I have to take a scale and mark of 7 centimeter. So if I'm taking 7 centimeter here, I should have to keep it like, take the accurate position here. And then I have to just mark 7 centimeters. Okay, all right, I'm taking 7 centimeter outside the circle like this over here. And the second one to be from 7 to 14 like this one here. So like we are getting 2 points each at a distance of 7 centimeter from the center. So I have to mark here P and here I mark it Q. So I've taken 2 points here P and Q. Now we have to take PO as the first point. So P as should be the first point we take to draw the tangents. So you can take either PO or OQ. So first I'm taking PO. So taking PO, you have to draw the perpendicular bisector of PO. For that we have to take more than half of the line segment PO and draw an arc here on the top and on the bottom like this. Again, taking a point, taking on the point P, we have to draw 2 arcs, one on the top and one on the bottom. So here I'm starting with the bottom and here on the top. So now we have got 2 intersecting points. These are the intersecting points, and we have to join the intersecting points such that they touch the first line segment PO, making it equally divided in the ratio 1:1. So we have to join the intersecting lines. Just take a sharp pencil for accuracy, as I mentioned before, and then we have to join them like this. So here we join it like that. So then we get that, suppose this point is N, then this N is the midpoint of PN and OQ. So we know ON. So we know that half of 7 is 3.5. So we need to take 3.5. We need to check whether we get 3.5 here. Here you can see that I get 3.5 here and another 3.5 here. So we see that they both are accurate. So similarly, the next one is to draw the perpendicular bisector of OQ. So I take here more than half and draw one on the top, as you can see here, and the other one on the bottom. And the same way, I take Q, one on the top, one on the top, and one on the bottom. And we have to join the intersecting line, and such that they intersect the line segment PO, I name here M, such that they're divided in the ratio 1:1. So here also I name it M. So if I'm naming it M, then we have to say that OM must be 3.5. We know that OM is 3.5. So our construction is accurate till now. Then we have to draw two circles, one with center N and the other one with center M. So first we'll draw with center M. If we're taking center M, we need to take ON or PN as our radius. So here I'm taking PN as the radius. Here I'm taking PN. So you just check it out whether they get accurate here. So if I'm joining that out, we see that they just meet the center point. Then take M as the center. Since both are supposed to be the same radius, take OM as the radius or OQ as the radius, and then draw another part. Let it intersect the primary circles at the points that we have set first. You can see that they intersect the primary circles at these points. So I have drawn two circles here, one with center M and the other one with center N. The next is to mark the points where it intersects. So here, if I'm marking it as S and here it as T, then here I will mark it as W, and here I'll mark it as, suppose if I'm marking it as L. We have to join PT and PS such that PT and PS are tangents from the point P to the circle. Like this, I'm joining PT and PS, as you can see here. I'm joining PT and PS, PT and PS, because P is the external point we take here. In the next one, we are joining QW and QL, because QW and QL, W and L are the intersecting points, and QW and QL are the tangent to the circle. So they, of course, intersect each other here, but we don't need to mark that. That's not in our topic here now. So just we need to go through the tangent. So here we have to join QL now. After joining QL, we have completed the construction of this one. Now here we can check the next one we have to do is justification. So for that, we just need to join either OS or OL or OD or OW. So here I'm joining OS to be more accurate, or you can join any of the sides. Now here I'm joining OS with dotted lines or partial lines, and then I'm marking here 90 degree. Now here, the next part is the steps of construction. The steps of construction can be easily written like drawing a circle of radius 3 centimeter and taking 2 points PO and OQ, both equal to 7 centimeter outside the circle, and then drawing the perpendicular bisector of PO and let N be the midpoint of PO, and drawing the perpendicular bisector of OQ and M be the midpoint of OQ. Then with N as the center and PN as the radius, we are drawing one circle, and with M as the center and P and OM as the radius, we are drawing another circle, and let it be intersected in the primary circle at points S, T, W, L. Joining PS and PT, they're the first required tangents, and joining QW and QL, they're the second required tangents. The last part of every construction is justification, and here also we have two types of justification, either to prove that PT, PS, QW and QL are the tangents, or finding the length of the tangents. So here they have not asked us to do any method, because the last question, the second question, there was a part where they asked to find the method by actual calculation. So there we have to justify the length. Here we can do any justification. So as I've said in the first video of the question 1, we can do two justifications, either by using this angle in a semicircle rule, where POS, this part is an angle in a semicircle. So this is a semicircle. So angle PSO is of course an angle in a semicircle. So we bring it 90 degree, and then we can prove that PS is perpendicular to OS, where OS is the radius. OS is the radius, so we can say PS is of course the tangent to the circle. Similarly, we can prove that all these three, QL, QW, PL, PT, are all tangent to the circle. The second method is to find the length of the tangent. In such a case, we have given here what our length is. Suppose if the length given is here the 7 centimeters, so we can just join OW2 like using a pencil. We can just join OW2 such that there is tangent to both circles. Okay, you'll get here OW, here OW. So we have just proven that the first type of justification. The second justification is the length of the tangents. In such a case, what we have to do is, we know that this is 7 centimeter in length. We know that OQ is 7 centimeter in length. So it is the question itself, it is given, it's 7 centimeter in length. The second part is when this OW and OS are the radius. So in such a case, OW is equal to 3 centimeter. That's also given in the question. So OW is the radius of the circle. Then using that, we can find what is QW. So in such a case, we have to use the Pythagoras theorem, where OQ is the hypotenuse of the triangle. So 7 square minus 3 square. So we'll get it's 49 minus 49 minus 9. So this will be root 40. So finding the root of 40, we find that the root of 40 is 6.25. So 6.25, we can just check it out. So here we find that the length we get is 6.3 averagely. So we can find that our construction is overall much accurate, because we get 6.25. So that is almost equal to 6.3 here, because as I said in the last video, we can have a distance of 3 centimeters back or forth when we are doing this construction. So here we can check the PS1 also. Here also we get 6.3. So it proves that our construction is accurate. Thank you guys for watching my video, and subscribe to my channel for more videos. Thank you.